So let's say I give you this equation. I ask you the question, when is the x velocity the greatest? Would you be able to give me the answer? If not, then continue watching the video and we'll go through it together. So the important question to ask ourselves, how can we actually find when the velocity is greatest? So the key principle to identify to help us solve this question is that the x velocity is greatest when the x velocity stops increasing and starts to decrease. We can better understand this point if we look at a graph. So if we plot a random velocity graph here, we can see that the maximum velocity is at this point where we can see that the velocity stops to increase and starts to decrease. And an important feature to note about this point is that the slope is equal to 0. We already know this equation here that the change in velocity over change in time is equal to the acceleration, as well as we also know that when we take the derivative of a random function with respect to its independent variable, in this case it'd be dt, we're just going to get the slope. Thus, when we take the derivative at a specific point, we can get the slope tangent to the curve at that specific point. For us, our function is the velocity and our slope is equal to 0. So if we plug this in, we get this expression here. This equation yields when the slope is equal to 0, which is the same as when the velocity is maximum. As we can see, the velocity is maximum when the slope is equal to 0 on the graph. Now we can solve for when the velocity is max using this equation. We write it in this form just to make it more clear. So then we can plug in the velocity equation that we are given. And we get this expression here, just noting that we disregard the units for now just to make it simpler. And then we can distribute the derivative into each term and we get this expression here. And the derivative of a constant is 0. And then the derivative of the second term is just going to be 2. For the third term, t squared, we can bring down the 2 and then subtract 1 from it. And we get this expression here. Now we can bring the units back in just to make things make sense. And we get this expression here. Isolate for t by bringing t to the other side. We can multiply the whole expression by 1 over 0.1 meters per second cubed to isolate for t. Now we have t alone on the right hand side and we just have to compute this here. 2 divided by 0.1 is equal to 20. And if we do meters per second squared divided by meters per second cubed, we just get seconds. And our final answer for the time when the velocity is maximum is 20 seconds.